Hello, and welcome back to Summarize Science. Today, we're looking at a fascinating paper that could revolutionize how we control assistive robots with our minds. Brain-computer interfaces, or BCIs, hold incredible promise for people with limited mobility, allowing them to operate devices like wheelchairs just by thinking. However, a major challenge has been making this control smooth and natural. Most current systems are limited to clunky, discrete commands like go forward or turn left, rather than allowing for continuous, real-time adjustments. This is where the researchers proposed a radical new idea, inspired by a concept called embodied cognition. The theory is that the brain doesn't think about movement in terms of simple velocity, like a car's speedometer. Instead, it thinks in terms of dynamics, the forces needed to create motion, which is best represented by acceleration. Essentially, the brain is constantly calculating how to change its movement, not just what the movement is at a single moment. To test this, the researchers used a public dataset where people controlled a cursor on a screen by imagining hand movements, while their brain activity was recorded with EEG. The task was to continuously follow a moving target, which requires constant adjustments. They then created a new Bayesian learning model to decode these brain signals and compared it to other standard methods. Crucially, they tested two different scenarios. In the first, they asked the models to predict the user's intended velocity. In the second, they asked the models to predict the user's intended acceleration. The results from the acceleration test were absolutely stunning. As you can see in this chart, the new Bayesian method, shown in the middle, had a dramatically lower error rate than the other models. In fact, it reduced the error between the predicted and true velocities by an incredible 72%. But here's what makes the finding even stronger. When the models tried to predict velocity directly, there was no significant difference between them. They all performed about the same. This provides powerful evidence that acceleration is the more natural language for the brain's motor control system. What's truly mind-blowing is that this preference for acceleration-based control was found in a task involving only imagined movement. This suggests that our brain's internal model of our body and its dynamics is so fundamental that it's active even without any actual physical motion. So, let's recap the important points. First, decoding motor intentions from brainwaves is far more accurate when you focus on acceleration instead of velocity. Second, this supports the scientific theory that our brain's control of movement is fundamentally grounded in physical dynamics, a concept known as embodied cognition. And third, this new approach offers a clear path toward creating more intuitive, stable, and efficient BCIs. In the future, this could lead to assistive wheelchairs that feel less like a machine you're operating and more like a true extension of the user's body. It's a huge step towards making human-robot interaction more seamless and natural. Thanks for watching Summarize Science.